Good afternoon, guys. Shall we start now?
Yes, ma'am.
We will start. Okay, I will share my screen. We will revise the previous thing. Then we will start with the today's part. Okay. Let me share you my screen. Yeah. So in the last session, we have learned about basics of a DevOps. Okay. So what we have learned is that what is a DevOps, why we need DevOps, what is the DevOps life cycle, what are the different tools which we require in a DevOps. Then what is the agile methodology? Just we have seen the introduction. Remaining thing we will see in the today's class. Okay, then what are the DevOps principles? What are the different tools that we are going to use in a DevOps? And what actually works a DevOps engineer will do? What are the tasks and what sort of activity will be the DevOps engineer will do? Then what sort of jobs are available if you learn as a DevOps? Okay, what are the roles and responsibilities are there for DevOps? These are the all basic things we have seen in the last session. We will revise today just for 5 to 10 minutes. Then we will go with the next session. Okay. Okay, sorry guys. So let's move with the next slide. So then we have seen what is mean by DevOps. As the name suggests, it is a combination of dev plus ops. That means development plus operation. So in basically DevOps, both development team and the operation teams are working together. Okay, when they work together, they provide many type of advantages. For example, it may reduce the communication gap between the DevOps team, operation team, and the production team or the tester team, we can say. Okay, so what are the advantages that we will see in the later slides? So just right now, try to understand what is the basic definition of a DevOps. Okay, so as the name suggests, it is a combination of two words, that is the development and the operation. And what under the DevOps, there are different operations will be performed under this DevOps. And here the main objective of a DevOps is to deliver faster and customer needs satisfaction. Okay. These are the main things that we are going to add. Next, we have seen what type of challenges the development team are facing and how we can overcome that challenges with the help of DevOps solution. Next, we have seen what are the operation team challenges and how we can overcome that challenges with the help of a DevOps. If you see these slides carefully, what challenges occurred by the operation team? So uptime maintenance is difficult. Why? Because when we are upgrading some changes or some versions in your application, the software or your application may go down, isn't it? So to avoid downtime or maintain uptime is also quite difficult for the operation team. Then automation tools are not effective in earlier scenario. Monitoring was quite tough. And then feedback was not given properly from either from team or from client or end user. So these sort of challenges are overcome with the help of your DevOps. Okay. Next, we have seen waterfall model. This is a software development lifecycle model. So we have seen waterfall model. These are the different phases for the waterfall model. And these phases work in a forward direction. For example, once you reaches to the second phase, we can't go back to the previous phase. If you want to go, it may occur lot of financial problems as well as it is time consuming process also. So this is the structure of a waterfall model. Then we have seen what are the advantages and the disadvantages of the waterfall model. So to overcome that disadvantages, they have introduced a new model, which is nothing but your agile software model. So agile model is an incrementing and iterative structure where each iteration will be called as a sprint. Okay. So here each iteration will again go through the 5 phases. What are the 5 phases? If you see carefully, requirement analysis, then planning of the sprint. Each iteration will be called as a sprint in simple word. Agile model will develop software in an incremental and iterative fashion. Okay. So each iteration will be called as a sprint. Okay. So first of all, gathering requirement for the planning actually design process start. As I told you, when the design process, they will actually design what type of classes will be there, what type of diagrams will be there. For example, what will be the different states for an application, how the different module communicate with each other. For that, all we have a different diagrams, and all these diagram will be developed, or we can say one overview or flowchart of the code will be developed in this design phase. Okay, once the design phase completed, it will go towards the actual coding and the testing part. Okay, once the coding and testing part will be done in the 4th phase, once coding and the we can say testing completed, it will go to the review and monitoring phase where the actual application will be deployed, and then review from the end user or the client will be taken for the consideration. Okay, again the second iteration will start. So each iteration will be called as a sprint here. Okay, and in the first iteration, a small or the we can say when they are taking requirement from the customer, they will prioritize the work. Okay, so most priority work or highest priority work, we can say priority work will be taken first. Okay, then first iteration, then they will take feedback or some changes from the first iteration, and that will be carried out for the second iteration. Okay, so like this, one software will be divided into multiple parts, and then highest priority part will be taken first, and then next iteration will be carried out. Okay, so this is the agile structure. Then we have seen what type of advantages and disadvantages are there in the agile model. Okay, next, we have seen the actual scenario where in waterfall model, there is a gap between customer software requirement and the developer. Okay, which was overcome by the agile model. But in agile model, there is a gap between development team and the operation team. Okay, so that gap will be reduced with the help of a DevOps. Okay, again DevOps definition we have seen. Yeah, DevOps life cycle. So what are the different phases are there in the DevOps life cycle? So it is started with a plan. Plan is the first phase. Then code, build, test, release, deploy, operate, monitor. Again, it will start from the phase. As you see carefully, this is an infinity symbol. Okay, what is this? This is an infinity symbol in which these tasks are carried out in a not ending scenario. Okay, for example, they will, when they got the requirement, they will start planning for that requirement. Okay, after the planning, they will start coding. After the code, they will perform build operation where the actual code will be clubbed together. After the build, they will perform test operation. After the test, it will be released. Okay, after release, it will be deployed on the actual production environment. Then operation team, actually it will be operated by the end user or the client, and then monitoring will be carried out. After the monitoring, whatever feedback is there, that feedback will be provided, and according to that feedback, some changes will be performed, and again the cycle will be continued. So if you see, this is a never ending process. That's why the infinity symbol is given here. And these are the different phases of a DevOps life cycle, we can say. Okay, so this we have seen in the last scenario. Next, so we have seen software development lifecycle phases. Okay, what are that? Continuous development, continuous integration, continuous testing, continuous monitoring, virtualization, and containerization. Okay, So what is a continuous development? What it means? So these are the different phases. Okay, continuous development means uh, whenever a code or a module or a feature is developed by a developer, immediately that will be deployed on your actual production environment, or it will be provided to the client with a no downtime. Okay, immediately it will be deployed on the production environment. Then continuous integration. So in the existing code, we can say new modules will be integrated and immediately it will be compiled, it will be tested and it will be built. Okay. Then continuous testing, continuous monitoring and virtualization, containerization, we will see later in a detail. Okay. So I hope you understood the meaning of these words. Next up, roles and responsibility of a DevOps engineer. So these are the few tasks a DevOps engineer have to perform in his day-to-day activities. We can see continuous integration and continuous deployment is the main task. Then infrastructure automation with the help of some infrastructure as a code tools. What are the infrastructure as a code tools? We know Terraform, isn't it? So with the help of Terraform, they can create environments, production environment or any, it can be a testing environment or it can be staging environment. So we can create with the help of infrastructure as a code tools. Then configuration management will be done with the help of Ansible. Monitoring and performance optimization will be done with the help of Prometheus, Grafana. Then collaboration and communication. Then cloud infrastructure management in AWS. There are different services provided or resources are available. So how to manage that cloud resources, security and compliance, incident response and troubleshooting, continuous improvement, technical documentation. So these are few theoretical part actually. No one will ask you in detail, but if they ask a few basic questions, you should know about these things. Okay. Then once you learn the DevOps, you can apply for these sort of jobs. Okay. You can apply as a release manager, DevOps lead, DevOps automation expert, the DevOps testing professional. If you have basic knowledge of a Selenium, MySQL, or unit testing, TestNG framework, API testing, then you can apply for this job. Then DevOps architects, if you are familiar with some basic languages like C, C++, Java, Ruby, Python, you can apply as a DevOps architect. Then DevOps engineer, Linux, AWS, Azure. If you know the basic cloud plus these Jenkins, Git, these tools, if you know, then you can apply as a DevOps engineer. Okay, these are the few options available when you are working, when you learn the basic things as a DevOps. Okay, so this is what we have seen up till the last session. Now today we will go with the next part. So I want to introduce you little bit about agile methodology. Okay, in case if they ask questions, you should know a little bit. Okay. Yeah, I think so. My screen is visible. So what is the agile methodology? Okay. So it's a project management approach that prioritizes cross-functional collaboration and continuous improvement. It divides the project into smaller phases and guide teams through the cycle of planning, execution, and evaluation. Okay. So here, what they are trying to say, it is a basic definition. I copied it as it is. So in our agile methodology, instead of starting developing whole project from the scratch, what we are going to do, basically we are going to uh, so if you see here, sorry guys. So if you see, Here actually what we are going to do here. Okay, fine. So instead of starting developing project from the scratch, what they are going to do, they are going to divide the project into smaller phases. That means if this is the whole requirement, okay, this is the whole requirement, this document content. So first part is there, second part is there, third part is there, okay. These are the requirement from the customer end, okay. So first requirement is something like providing GUI, second requirement providing database, third requirement is something like storing the data or providing security. Okay, so these are some requirement which is provided by the client or end user. So instead of uh, start developing project from a scratch, what they will do, they will divide the project into some small phases. So this is the first phase, this is the second phase, then this will be the third phase, and then instead of starting everything, we will plan only for the first phase. Once the first phase completed, then we will go for this second one. Okay. So here phase is not like a waterfall model. What we are trying to say, we will break the requirement into small parts. Okay. So after breaking the requirement, first part, or we can say first part we will develop. Okay, we will do the testing. We will show it to the end user or customer. We will take feedback from the end user and customer, and then only we will go for the second part. Okay. So after the first part completion, we move to the second part. Okay. When the second part is completed, then only we will move to the third part. Once the third part completed, then fourth part. So here requirements are divided in small groups, or we can say small phases. Okay. And then each first team will work on this first phase. See guys, sorry. So it will be whole project or whole requirement are divided into small parts, and then that part will be developed. So here first iteration will be called as the one sprint. Sorry guys, my daughter is troubling me. So what we are going to do in agile methodology, a whole project or whole requirements are divided into small part, and when the first part is developed, then and then only the team will go to the second part, and this first iteration will be called as the sprint. Okay, first iteration will be called as the sprint, and the team which will work on this sprint will be called as a scrum. Okay, So you might have heard this word. So what actually will happen? In agile methodology, the whole project will be divided into small parts. And in each iteration, first part will be developed, then second part will be developed, and whatever changes they got from the first part, that will be carried out, that feedback will be carried out for the second part development. And this first iteration will be not first, each iteration will be called as a sprint, and the team which works in this sprint will be called as a scrum. So the team leader will be called as a scrum master. Okay, if you see here, the team leader, okay, or the person who holds up the team will be called as a scrum master. Okay, then product owner will be there, is nothing but actual client, and then scrum team, the rest team. Okay, so these are the three members which are actually involved in this each and every sprint. Okay, so in simple word you can remember something like this. So each iteration will be called as a sprint, and each iteration have a different phases. Like each iteration or each cycle will go through the all phases. What are the phases here? Requirement gathering, design, develop, test, deployment, review, feedback. Okay, so first part will also go through the all phases. Second part will again go through the all phases. Third part will again go through the all phases. Okay. So what are the phases? These are the 5 main important phases. You can say requirement gathering, design, develop, test, deployment, review, and feedback. Okay. So main important thing you have to remember is about sprint and the scrum. And who are the involved in the scrum? Scrum master, product owner, and scrum team. These are the 3 important members we can say who involved in this sprint. Okay. So this is all about agile methodology. I think so same thing, sprint. Each iteration of a scrum is termed as a sprint. A product backlog is a list that contains all the information needed to create the final product. Okay. What it means? The product backlog means whatever pending in the first iteration, that is nothing but a backlog. Okay. What is pending in the first iteration will be considered as a backlog. Okay. So that backlog will be considered for the second iteration. Okay. Then top user stories from the product backlogs are chosen and translated into the sprint backlog during each sprint. Okay. The team works on the sprint backlog that has been established. And this is the basic things actually. The team double check the everyday job and team deliver product functionality at the end of the sprint. Okay. What will be the duration of this sprint then? We are saying the sprint is the one cycle, but what will be duration? So it is actually 4 weeks, but it varies company to company. Okay. It's actually 4 weeks, but it varies company to company. So this is all about agile. Actually, it is not included in your syllabus, but I thought to give you some basic information. Okay. So everyone is clear about this? Is there any doubt in this? You can put on your camera, or else you can text in the chat box. Okay, fine. So this is basic things about agile methodology. Let's move to the next part. So today we will start with a Git. Okay. So let me close this and start Git related PPT. Yeah. So the first tool that we are going to learn in DevOps is a Git. Okay. So what is mean by Git? So before that, we have to learn about version control system. What is mean by one version control system? Okay. So in basically we can say, okay. So for one project, we can say different versions are available, different files are available. Okay. All the files are generated. That means one first version will be there, second version will be there. Like that, for every application, multiple versions will be generated. Okay. sometimes we need to switch between different versions. For example, right now, if you are working on the third version, again, you may require the first version or whatever changes you have done in the second and third version, you don't want that changes. You want the basic project which you have developed in the first version, isn't it? So switching between different version is also important. So we need something which will manage these versions. Okay. So a version control system, we can say, is a way to manage files and directories. It also used to track changes over time. It is used to recall previous version. As I told you, if there are multiple versions are available, then we need to go back to the previous version. Sometimes we want to discard the changes, whatever we have done. So in that scenario, what we have to do, we want to go back to the previous version. Okay. In simple scenario, this is the first product that we have developed. Okay. We will call it as a version 1. Then we we did some little modification and we, okay. So this is the second version which we have developed. Okay. After the third version. So now you realize that whatever changes you have done in the second version and third version are wrong. Again, you want to go back to this previous version. Okay. So how is this possible? How we can discard all the changes? If we are there is 1,000 or 2,000 lines of code, it will be highly difficult to remember what changes you have made, on which line you have made changes, isn't it? So in that scenario, if we can simply go with the this version control management system, where it will maintain all the changes whatever we have done in terms of commits. Okay. And it will recall the previous changes, and it is a way to manage files and directories. Why? Because here in version 1, this is the whole application, but it may contains multiple files, isn't it? So it manages files, directories, subdirectories, everything will be managed with this with the help of version control system. Okay. So how it is evolved, what is the history behind this? Okay. So initially, we have a source control system in 1982. Let me write here somewhere. So first in 1972, sorry, 72. 1972, initially, source control system was there. Source control system. Okay. It was an open source and it was a part of a Unix. Okay. Whenever they have developed a Unix operating system to share the kernel based code, we can say Linux kernel code, they have developed the source control system in 1972. It was open source. Again, they modified it, and in 1982, again, they have developed a revision control system. Okay. The revision control system with some new features, we can say, with some added advantages. Okay. Let's not go in detail like what are the features are there in source control system, then what are the features in revision control system. If we try to add everything, it may take times, or classes will also increase. That to be unnecessary. Okay. So I'm telling just a basic overview. Then 1986, again, concurrent version control system was developed. Concurrent version control system. In 2000, Apache subversion control system developed, which is called as a SVN. I think so you might have heard about it. Okay. Then next in 2000, BitKeeper was developed. BitKeeper was developed. Okay. But if you know carefully, this revision control system, concurrent control system, Apache subversion, everything was an open source. But BitKeeper was a closed source. What is meant by open source and closed source? Okay, so source code is available. If it is an open source code is available for everyone to do the changes. But BitKeeper was a closed source control system, and it was a distributed version control system. These all are centralized, but this was the distributed version control system. And mainly it was used with a source code management for Linux kernel. Okay. After in 2000, next they have developed is the Git. Then they have developed the Git. Okay. Git was developed by Linus Torvald in April 2005. Okay. In 2005, Git was developed. And it was developed by Linus Torvald. Do you know who is this? So Torvald was the one who developed actual Linux system. Okay. So it was replacement. Git was the replacement for the Beatkeeper to do some Linux kernel changes. It was command line version control system. What is meant by command line version control system? So by using command line like your terminal in Unix or CMD in Windows, by using command line we can operate with the help of command line we can operate with a Git. Okay. It was also distributed version control system. If I say distributed version control system, what it means? I'm saying that these are the all centralized version control system where Git Bitkeeper are the distributed version control system. What it means? So I will show you one slide. Wait a while. So if you see distributed system, what are the version control systems are there? Concurrent version control system, subversion control system, Mercurial and Git. These are some example of version control system. Okay. Uh, and then distributed version control system, we have a Mercurial, Git are the newer and are gradually replacing centralized version control system like concurrent and subversion. Okay. Concurrent and subversion are centralized, whereas Mercurial, Git are the Git and this Bitkeeper are the distributed version control system. So let me show you what is meant by distributed and what is meant by centralized version control system. Okay. So we can say this traditional is nothing but centralized version control system and this one is a distributed version control system. So what is the difference between these two? So if you see carefully, there is one server and one repository is attached to this server. Now what this repository holds? It holds. Yeah, sorry guys, tomorrow I will change the timings. I will take in the morning session. So let's see here. So if you see carefully, this is a centralized version control system and this is a distributed version control system. So for a server repository is attached and this repository holds your applications or we can say softwares and all the versions of that applications, all the files, folders, subfolders, everything will be stored in this repository. And then multiple clients will be attached to this to this server. Okay. So whenever client wants some data, what he will do? He will send a request to this server. Server will fetch the data from the repository and that data will be sent to the client as a response. Okay. So if you see all the data is by default stored at a server side. Okay, all the data, everything is stored at a server side. So whenever client required, then and then only he can able to access the data with the server's permission or when the server provides the data. But what if the server goes down? If any case, because of some problem or something, some natural disaster or something, some network related issue, this server goes down. Okay, the server got crashed. So all the data, whatever stored in the repository will get discarded or it will get vanished. It will get permanently deleted. So to avoid that sort of scenario, then they have introduced one distributed version control system. So what is mean by distributed version control system? So along with the server, every client will have their own repository. Every client will have their own repository And whatever data generated by the client or fetched from the server will be stored in this repository. Okay. So in any case, if the server goes down, then the copies of that data will be stored at the client side. Okay. Even the server goes down, the clients will communicate with each other and they can exchange the data. Okay. So like here in the traditional scenario, if the server goes down, then all the data will get discarded. Okay. That sort of scenario will not happen with the help of distributed version control system, because each and every client will have their own repository. Now, how you will relate here? For example, I think so you might have heard about GitHub. Okay. GitHub is nothing but one sort of repository. Okay. So where all the application and data will be stored. But if you connect your laptop with the GitHub repository, you can generate or you can create your own repository here. Okay. So whatever files you are fetching from the GitHub repository, that files can be stored on your local system. So in this scenario, your local system will be work as your repository. So in case the GitHub account got discarded, all the data will be available in your local repository. Okay, that's why distributed version control system is very famous. Why? Because no central servers. Everyone is like a server only here. Everyone have their repository, everyone have their data. So there is no central server system. And every developer is a client, the server and the repository. Okay, as I told you, every client is nothing but a developer or a server, and they have their own repository. In case the server goes down, this client can communicate with each other and they can exchange data. Okay. So even though server goes down, it won't affect on the data, or it won't affect on the clients. Okay. So that's the reason distributed version control system is quite famous. So why version control system and why it is so important? So the main reason is for yourself and with, while working with others. When you are working with a team, or when you are working for a particular company, and all the members want to communicate with each other, okay, and they want to work concurrently. For example, if one project is there, consider this is one project, okay, and there are 4 developers are working together. Okay, these are the 4 developers. Okay, we will call it as a developer 1, developer 2, developer 3, and developer 4. These are the 4 developers. Okay, they all are working on a single project. Okay, and they are working at a time. Then how they will come to know how they can share the code? As we know, all modules are dependent on each other. Okay, the first module, second module, third module, and fourth module, and they are working concurrently. So how they can collaborate among each other, how they can share their code with each other, how they can merge the changes done by each and everyone. So to manage the things here, we will create one repository in the Git or GitHub account, or we will create one remote repository. Let's not call it as GitHub. We will call it as a remote repository. So for that purpose, what we will do to make a collaboration, we will create one repository that will be called as a remote repository. Okay. And the application, or we can say application structure, will be stored in the remote repository. Then each and every developer will fetch that structure and they will start working on it. Okay. They will develop the code, or they will do the work which assigned to them. And after that, once the work is done, for example, whatever module asked to them to develop, whenever that module is completed, they have developed the part, what they will do, they will push that code to the remote repository. Okay. Whatever initially they will fetch the empty template or the structure of that application, they will work, they will perform the coding operation, whatever assigned to them. And once the coding part is completed, what they will do, they will push this code to the remote repository. Okay. Now everyone have pushed their code to the remote repository. Next, what they have to do? Now here everyone's code is there, but it is still not connected with each other. 4 developers are there and everyone's code is there in remote repository, but still it is not connected, or it is not collaborated with each other. So To do the collaboration, what they will do, first of all, this developer one will send a merge request. Okay, that merge request will go to the team lead as well as team members. Okay, this merge request will go to the team lead as well as team members. Okay, then everyone will verify like whatever changes done by the D1 or whatever module developed by the D1 is correct or not. Is it as per the requirement? Okay. So after this, we can say review, the formal review. After the formal review, the merge request will be accepted and the code will be merged into the remote repository. Okay. Then second developer also same scenario. Whatever he have developed, he will push it to the remote repository. But still it is not added into the actual application. Then he will send a merge request. He will ask, please add my code or merge my code into the remote repository. Then again that request will go to the team members and team lead. Everyone will verify that code, and again that once if it is everything is correct, that code will be merged into the actual repository or actual application. Okay. Then third and fourth will be the same scenario. Okay. So directly you will not merge the code into the remote repository. First you need to push that into the remote repository and you need to send request for the merging. Then how you will push? So how you will start creating code? So there will be different branches will be there for this remote repository. As everyone wants to work as an individual developer, they will create one branches. Okay, everyone will create one own branch, we can say. Okay, so for D1 we have one branch, for D2 one branch. So for this remote repository, or we can say the empty template which is created for your application, this empty template will have a multiple branches. Okay, this empty template will have multiple branches. So maybe D1 will work on initial branch, then second branch, then third branch, then fourth branch. So separate branch will be created and later you can merge that branch into the remote repository. Okay, these are the options are available. So either you can work directly on that central code, whatever you have fetched from this remote repository, you can directly work on that. Instead of that, you can create one branch and later you can merge that branch into your remote repository. So each developer will have their individual branch. They will perform their coding part and then they will send the merge request for that remote repository. Okay. This is the basic scenario. Okay. So to do all these things automatically, we have a version control system, and the version control system we are going to use here is a Git. Okay. Many are there, but we are going to use Git. Okay. Mercurial is there, subversion control system is there, concurrent version control system is there, BitKeeper is there. BitKeeper is also very famous. But right now we are going to learn about Git. Okay. So this is the overall structure about Git. Do you have any doubt in this? You can text me in a chat box also, no problem. Okay, so let's move to the next part. Okay, so this is about version control system. Okay, so what is a Git? So again, it is created by Linus Torvald in April 2005. It is a replacement for the BitKeeper, as BitKeeper was a closed source and the source code was not available for this. Okay, and main purpose is to manage Linux kernel changes. It is also a command line version control program. It is uses checksum to ensure data integrity. What it mean by checksum? So some, we can say, encrypted code will be generated. Okay, here checksum is nothing but encrypted code will be generated to ensure the data integrity. And it is a distributed version control system like BitKeeper. It is a cross platform. That means it will work on Linux, Windows, then Ubuntu, Okay, Mac OS. So that's it is a cross platform. It is open source and it is a freely available. You can create your own account and you can access it. Okay. So let me take you to the GitHub repository. How we can create account in a GitHub. Okay. Let's start with that. So fine. So Git login. I think so. I am already logged in. So I will show you just. Now let me log out. So this is the official website for the GitHub. If you see here, okay, you have to click on sign up. Okay, so you can enter your email ID, whatever you want. You can add your email address here and then click on continue. Why? Because it is showing invalid email. I think something is wrong. But if you add correct email ID, what it will do, it will send one token here to your account or one link to your account. Okay. Because I already have 2 or 3 accounts. So simple, you add your email ID here and then click on the continue. It will send you a token. And if you go to your email account or Gmail account and then click on the token, it will directly allow you to log in into signing into your GitHub account. Okay. Okay. Yeah, you can enter your email ID, no problem, because I already have account. It is saying that already taken. Okay. These all email addresses we have already used for earlier batches. So you can continue, you will get one token. Okay. You can easily sign in here, no problem. Okay. So once you log in into your GitHub, if you see, this will be the dashboard for your GitHub. Okay. This will be the all repository which I have created. Okay. And let me give you just a basic overview of this. Okay. So here you can say this is your account. Okay. These are the 3 accounts which I already added. Then you can see these are the all repository which I have created earlier. Okay. So if you see the structure, here you can see, first of all, Mani Kalyani 2 is my it is my username and later the repository name will be there. This is the repository and this is the username which I have created. Okay. So after username you slash and then repository name will be created. Okay. So this is a simple dashboard. From here, if you click on the new, you will redirected to the another page which will allow you to create the repository. How we can create, I will show you later. First of all, just try to understand the dashboard. These are the all repository. Here you can search for the particular repository which are available in your system. Okay. Then next, here you can create, you can import the existing repository. Okay. Then if any issues are there, it will be reflected here. Then pull request, merge request or pull request. If any pending, it will be shows here as a notification. And these are your actual notification. Okay, and this is your account. So here your profile, your repository, your project, your code space. Here actually you will do the coding. Okay, your organization. These are the all tabs will be available. These are not required actually, but these are important. Your repository, your project, your code space where you actually do the coding, your organization, and then your enterprises. So this is the basic dashboard. Now let me create the repository. Okay. So if you can go here and click on new repository. So here no need to select any repository template. You can keep it as a no template only. Okay. Then next this will be the username. Here you can add the name whatever you want. Okay. So here I will add as a hello. Okay. So it will check in your repository whether it is taken already or not. Okay. So if you see hello is available, that means I have not created any repository with this name. Okay. So what is the repository here? What it means? So here repository is nothing but one space we can say where the all files related to a particular project will be stored. Okay. If I created hello, for example, my application name is nothing but hello. Okay. So if I create a repository with the hello name, later I can upload all the files which are related to that applications or software. So all the data related to that software application will be stored under this repository. So like that for every application, every software, we can create one repository. Okay. So description, no need to add here anything. We can keep it as empty. If you keep it as a public, it will be accessible to everyone. Okay. For example, now if I keep this public, this repository, hello repository will be available all of you. You can just, you need that URL and you can easily able to access that repository. If you keep it as a private, it will be accessible only by you only. Okay. And later you can allow the access. How we are providing access to this Google Drive, like that we can provide access to this repository also. Then add readme file. What is mean by readme file here? Okay, so this is nothing but a description about your project, some important description, some important messages that you want to provide about that project, some basic details about that project we can add into the readme file. Okay, then git ignore dot git ignore. If you see carefully, this file start with a dot. So what is meant by dot git ignore? So while uploading your application into the GitHub repository, if you don't want to add few files, for example, it can be a binary file, it can be a Boolean file, so it can be some PDF files or text file, which you don't want to add in your application. That file we can write into git ignore. How we can add git ignore, how we can write file, we will see later. Don't bother about it. Okay. Right now, just I am explaining you things. Okay. Uh, Tomorrow onwards, we will see all the things practically. Okay. Then license, no need to choose. You can keep these things blank. And now I will not add even readme file also. I will keep it as a public. And then see, I'm not adding much more details. Okay. Initially, we will not create confusion by explaining all the things. What I will do, this is your username. This is your repository name. Description, I will keep empty. I will keep this repository public so that it can be accessible to anywhere and from anywhere and to anyone. I will not add readme file also. Okay. And I will not add git ignore file also. Initially, I will keep it empty. Then click on the create repository. Okay. So you can see the repository is created. Now I can create new repository on the command line. For example, if I go to the command line, with the help of this command, I can create this repository. This will be the URL for my repository. Okay. In the command line, I can initialize an empty repository. What is this Git init? I will explain you while we are going with the practicals. So just try to see here, try to understand the things. Okay. Right now, okay. Right now, these things are not mandatory. I will just try to understand the heading. Okay. I will explain you tomorrow all these commands. So we can create empty repository with the help of command line. For example, if you we can go to the uh, command prompt in your Windows or terminal in your Ubuntu, and if you follow these commands, one empty repository will be created locally. Okay. Then next, push an existing repository from the command line. So if you are already project in your system, you already created one application and that is already available in your local system. And if you want to add whole application into this particular repository, which repository I have created, be carefully, hello name repository I have created. Okay. So you can see this. This is the URL, github.com. This is my username. Manikalyan is my username. Okay. And this is a repository name. So if already code is available in my system or on my machine, then by using this command directly I can push all this, all that code or all that application into GitHub repository. Okay. So this is one options and we can import code from other repositories also. That you join newly the company, you have to pull the existing repository. Am I right? You have newly joined and you started working on a particular project. But maybe some people are already created repository and they're already working on that project. So what you have to do now? You have to import that code or import that repository in your account directly. Okay. So these are the three options are there. We can create new repository through command line and we can add remote origin to that repository. Or else if code is already available, we can push that code into your remote repository. Or else we can import the code from other repository. These are the three options are available. Okay. How we can do that, we will see while we are actually doing. Now let's move toward the installation part. So I think so everyone is clear how we can create account and how we can create repository. Okay. These are the basic things are there. I will explain you all the things, but slowly. Now, if I explain you, you may get confused and you may forget. Okay. So just try to create account in a GitHub and try to create some empty repository. This is the basic things that we want to do. Okay. Next up, we will move towards the installation part. Okay. So let me create one AWS instance. So let me create instance. I hope everyone have created account in AWS. I think so. Existing instances already have. Let me check whether Git is installed in existing instances. You can directly connect from here also. No
Ma'am,
need to third-party software. Okay.
hello, ma'am.
Yeah, tell me.
Ma'am, this Git is used by the DevOps people, na?
No, Git is used by everyone: developer, tester, DevOps, even production team members. Everyone Git is using.
Okay. So how we as a DevOps people are going to use it?
See, the
Like we
actual
are
code, how
merging.
as a DevOps people, you will get the code in your plate, isn't it? For you, no need to develop code. That code
Yes,
will be developed by the developer, isn't it?
yes,
And
ma'am.
that code they will upload into the GitHub. Now, once the code
Okay,
is uploaded into the GitHub, the actual DevOps people work will start. They have to pull that code. They have to build the code. They have to write the Jenkins files based on that code. Everywhere you require Git only, na? For example, I will tell you one scenario. Developer have developed the code, whole application they have developed them and they have uploaded into the GitHub repository. Okay, or not whole application, even small part if they have developed them, they will first of all upload into the GitHub repository. Okay, from there a DevOps person will fetch that code first of all. After fetching that code from the GitHub repository, what he will do? He will build that code. He will generate artifacts for that code. Okay. So while generating, he need to compile that code. He need to test that code. Test in the sense basic unit testing. Okay. He will test the code and he will generate package of that code. Okay. One archive file will be generated. It may be the var or jar. What is that archive file? I will explain you later. So that the build or the package of that code will be generated. That package will be transferred to the tester, as well as that package will be transferred to generate Docker container. That package will be transferred to the Jenkins files. Then in Jenkins files also, while generating or we can say writing script, pipeline script, we have to fetch the code from the GitHub repository. Okay. And that pipeline script writing is done by DevOps engineer. Okay. So in every phase, we need to access with the Git. While creating a Docker image, while writing pipeline script, while fetching the code for the building purpose, for generating var file, for deploying it on the Tomcat server, for every purpose, we need Git. Okay, as a DevOps engineer.
and how it is a version control? How it control the
Yeah.
versions?
So for example, first version or application is developed. Okay. First version or application is developed. And then developer realized that whatever changes, he made some changes and then second version is uploaded. Okay. All the version will be maintained in the GitHub repository. So
Okay,
whatever first part developed, that will be the first commit. Second part developed, that will be the second commit. And each and every commit will be considered as a versions. Okay. For example,
okay, whatever the
you are,
updation is there,
sorry.
whatever the updation like updating in the applications,
Yeah.
that versions you're telling, na?
Yes. Whatever updation that performed. For example, five developers are working together. First person will develop, he will upload something, isn't it? Second person will develop, second person will also upload something. So may I call the first person's first version, second person second version? Is that okay?
All the people who are developing these codes all are developing the same code, like on
All are,
same project they all are working. So are they
yeah.
working on a different part of the project or the same part they all are working?
Sometimes they will work on the same part, sometimes they will work on the different parts also. Okay, if one person, we can say, if we consider scenario where each person work on different part. Okay, so for example, first person, he will upload his first version, then he only made some changes, he will upload the second version, isn't it, for the same part only. That means first part he uploaded some log file. Let me share your screen and explain you. Don't get confused. Let me share the whiteboard. So see scenario where now this is the actual application. Consider here. This is the one person, this is the second, this is the third, this is the fourth. Okay. One. These four people are working on different part. Okay. Consider. Whole application divided into four parts. First person is working on the first part. Okay. He developed the first part and he uploaded it here. Okay. So that will be the version 1. Again, he did some modification and he uploaded same code with some modification. Then it will be called as a second version. So how you will identify this is the first version, this is the second version. So this will be called as a commit. Okay, it will be called as a commit. So whenever he will upload some data into GitHub repository, that will be the commit. Whenever he will upload some data into the repository, that will be first commit, and that commit ID will be generated, and that commit ID will be unique. Sorry, that commit ID will be unique. Okay. So whenever he will upload some updated feature as a second version, the ID will be changed. Okay. That will be the second ID. Okay. So for first version, this is a commit ID. For the second version, this is a commit ID. Now he can easily move from this commit ID to this commit ID. This is nothing but version switching. So that's why different versions will be available in the GitHub repository for the same file or for the different file. If many people are working on the same content, then also it is possible. How it will happen then? First person information will be stored in the first commit. Second person information will be stored in the second commit. Third person information will be stored in the third commit. So easily we can do the version switching. For that we have operation like a reset and revert. So with the help of reset and revert, we can go to any commit or any version. Instead of calling here version, we will call it as a commit later. Okay. So any modification, any changes will be saved with the help of this commit. And by using this commit ID, we can go to any version. Clear?
This will take some time now. Like if we have uploaded a version first, like commit one. So after use sorry ma'am, the client will use or the people will use, and then only after we will go for the commit two, na?
No. It's not. If I did not send the merge request, then how the people will able to see? Right now, whatever work I have done, it will be in my branch only. I have not sent any merge request. Isn't it?
So merge
When
request will be the of the final commit. Like if we have commit like 5 times, so the
yeah.
fifth commit will go for the merging, right?
Any commit, any number of commit. Whenever we want, we are okay. These changes are final. I don't want to do any modification. Then I can send the merge request. After sending merge request, also we can do the modification.
Okay,
So
ma'am.
whenever we
But
are doing after case, if you do the
only one
modification,
only one commit will go for the merging, na?
not like that. All commits will go for the merging. So
Okay.
instead of, if you don't want to add all the commit, what you will do? If you can merge a single commit also, that is nothing but Git cherry pick. So among all commit, you can add single commit, or else by default, whenever we are doing the merge, all commits will be added into the main branch. Okay. All commits will be added. But if you don't want to add all commit, you can add single commit also. That will be done with the help of cherry pick. Okay. So that is one more concept we will see later. How we can add single commit for the merge request, how we can merge the branches. Clear?
Yes, ma'am.
Yeah. Any doubt is there? So how this
No,
version control, everything you will understand better when we are actually working with these things. Isn't it?
okay, ma'am. All these developers are doing for one application. like all these commits are for one application, then who will filter all these and prepare one proper application, like whatever the client needs? All these needs a filter, na? Like not everything can be go for the
I told you
this
na
thing.
that merge request will be shared with the team lead and team members. Okay,
Okay,
team lead will be there, manager will be there. He will verify, he will review the things, and then that merge request will be accepted for the main
okay,
branch.
okay,
That's the reason na everyone will take out their own branch, and in that branch only he will work. And later he will send the merge request for that branch. So there will be main branch and there will be sub branches. Main branch is nothing but your actual application template. And from that main branch, we can take out multiple branches. Everyone can work on their main, on their sub branches, and later they can send the merge request. Got it?
got it, ma'am. Got
Fine. Any other doubt?
it. No.
Yeah, fine. So you will understand all the things better when we are actually creating repository. We are merging the things. Okay. We are how we can perform pull push operation, that we will see later. Okay. So let me see. Share my instance. This is the EC2 instance which I have created. So the website which you have to follow is a gitscm.com. Okay. Gitscm.com. Let me gitscm download. This is the website. You can check out everyone. This is the website. From here you can download Git. Click on the downloads. Now mine is I think so Ubuntu instance I have created. Yeah. So for this they have already given the commands. You can see clearly Alpine is there. Then OpenBSD, Solaris,
It's different
DB.
from this.
Huh?
Git Bash is different from this.
Git Bash. Git
Git
Bash is a
Bash we are
CLI. Git CLI. They have introduced their own CLI. Once you install Git on your system, one terminal will be provided by the Git. That is nothing but your Git Bash. Okay. Either you can
Git Bash we
install
are
at the
using.
desktop Git. Sorry.
Git Bash we are already using for Linux. For Linux practice we are using it.
Ah,
So
then
it's
same
different.
only. That is only Git CLI. That is nothing but your Git CLI. Okay.
Okay.
Git terminal, for example. How you have Ubuntu terminal? Do you get that?
Yes, ma'am. We
CMD
use Red
Windows.
Hat.
Yeah, in CMD for Windows, like that. Git Bash is nothing but it is a Linux based. So you can perform all Linux on the Git Bash, Linux command on the Git Bash, because the basic, what we can say, the source code of that Git Bash is written in a Linux. It is supporting Linux operating system. Okay, so you can easily able to write all the Linux command on the Git Bash, and Git Bash is nothing but Git tool, command line tool. Okay, Git command line tool. Okay, so if you have Git Bash, then no problem. Directly you can write the Git command. Okay.
Okay. Okay, ma'am.
So let me install first of all. I need to update package first of all. Let me share you what are the other ways also there to install. Let me share you the things. Wait a while. I'm searching all the possible way to install Git. My screen is visible?
No, ma'am.
Let me share it. Okay. Actually, I did not get all the things. We can install Git as a desktop version. If you install Git as a desktop based version, then you will get by default CLI, Git CLI. That is nothing but your Git Bash. Okay, it will be called as a Git Bash in a Windows operating system. Okay. So here, instead of installing Git as a desktop based version, what I'm installing the Git package. So I have updated my system and I have used this command, apt get install Git. Okay. So if you run this command, you see carefully. See, already package got updated here, and if you see, this is the command I have used to install Git. Okay. So later, once the Git is installed properly, we can check Git version. Okay. Git hyphen version. I think so. It is already there in my system. And that's why no package is downloaded, but you will see many packages will get downloaded here. And then, or else what I will do, I will create new instance and I will show you how we can install desktop based application. If you install desktop based application, then by default Git CLI will be there. Okay. So anyhow, it is about 6 o'clock. So what we will do, just tomorrow I will create one new instance and I will show you regarding this Git bash also. Okay. So how we can check Git version with the help of Git space hyphen version. This is the command, or else other way is Git hyphen v. With this command also we can check version. What is the problem? Hyphen v. Git hyphen v. Why it is not saving? Okay, fine. Let me create new instance and then let me install Git again. Okay. So fine. So for today we will stop here. If you have any doubt, you can ask. PPT I will share to you. Okay, fine. So tomorrow I will show you the overall installation part. What are the different ways by which we can install Git? and how we can use Git terminal, and how we can use directly from our terminal. Okay. So all possible ways tomorrow I will show regarding Git installation. Instead of that, any